we can consider that particular data set as unlabeled data set. When data set is unlabeled, we can go for supervised learning. This is the crux of this problem. What is the pinpoint you need to remember here is when data set not having labeled column, then we can go for unsupervised learning. When data set is having labeled column, then we need to go for supervised learning. Okay. So usually clustering algorithms are used to perform the unsupervised learning. Okay, we'll try to understand what is clustering and all. Here the main point is the model learns to training itself from the data. Okay, these unsupervised learning algorithms learn itself from the data. Clustering techniques are one of the major techniques we are using to perform unsupervised learning. When we can able to perform unsupervised learning, when there is no labeling to the data set, then we can able to perform unsupervised learning. Okay, these are the points you need to remember. So at this point, I'm hoping that everyone understand when we can able to perform unsupervised learning. When the data set is not having any labeling, then we can go for unsupervised learning. Okay, what are the techniques we are using to perform unsupervised learning? Clustering algorithms are the major techniques we are using to perform unsupervised learning. Okay, next thing, if you see input data here, how we can say this particular input data is unlabeled? When it can become a label? When it can become label? Suppose by showing this particular fruit, if I am telling it is apple, then this is a label data. By showing this particular fruit, if I am telling it is watermelon, then it is a label data. These two things are not there, only data is there with me. Whether it is apple or whether it is watermelon, I don't have. Then this is an unlabeled data. Okay, when this unlabeled data given as an input to the algorithm, assume that here we are using clustering algorithm. When this particular unlabeled data given as input to the algorithm learns itself over the data, and based upon the common patterns, it can able to divide that particular data into two subgroups. One group is apple and one group is watermelon. Okay, algorithm learns itself on the data set and it can able to identify hidden pattern in the data set, and according to the hidden pattern, it is dividing the data set into two subgroups. One group having apples and another group having watermelon. What is the working procedure here means? It is going to identify common characteristics of the objects. Depends upon the similarity among the objects. These clustering algorithms can able to divide the objects into different groups. What is meant by similarity here? In this context, the color, the shape, okay, all are the features of this particular fruit. Okay, based on that, it is going to identify, and whatever the fruits having same features, all those features are grouped together and they are labeled as apple at the end. And here these are labeled as watermelon at the end. You understand the process of unsupervised learning. We are going to take an unlabeled data. That data we are going to provide as input to the algorithm. Algorithm learns from the data and it divides the data into two subgroups. Okay, two or three, any subgroups, depends upon availability of the objects. Based on the common characteristics of the objects, those objects are divided into different subgroups. Each and every subgroup we are going to call here as a cluster. Okay, so again and again I am telling, unsupervised learning is going to perform on unlabeled data or no labeled data. First thing. Okay, clustering algorithms are the important techniques used to perform unsupervised learning. How cluster algorithm works? It is going to learn from the data set by itself, and it is going to identify common characteristics among the objects. Based on the similarities, it is going to divide the data into different subgroups. Each and every subgroup we are going to call as a cluster. Okay, each and every subgroup we are going to call as a cluster. Here, clustering algorithms are classified into different types. Okay, one is partition-based clustering, and second one is hierarchical based clustering, third one is density based clustering, and fourth one is grid based clustering. Okay, first initially you'll see what is the partition based clustering and some example algorithms under partition based clustering. Okay, before we are proceeding to this, I want to ensure all of you understand what is unsupervised learning and when it can able to perform, what are the different techniques under unsupervised learning, right? Rajashree, can you tell me when we can able to perform unsupervised learning? You are there, Rajashree? Rajashree, you are there or not?
Yes, sir.
Yeah, when we can able to perform unsupervised learning? You know or not? Anyone in the class? When we can able to perform unsupervised learning? This is very simple. It clearly indicates that you are not at all listening to the class. I mentioned when data set is having label, it is used for performing supervised learning. And data
In the
set
data.
have label, then we can perform unsupervised learning. What is label? I have shown you 3-4 examples. What is the thing you are unable to understand? When last column independent variable is not there in the data set, that is an unlabeled data. Example, I mentioned bank customer details, but whether is good customer or bad customer not mentioned, then it is an unlabeled data. Patient details, all features of patients were given, whether he is going to get a heart attack or not mentioned, then it is an unlabeled data. Even a LKG student can able to understand this. When data set is having no labeling, then we can perform unsupervised learning. No labeling, unsupervised learning. What is meant by label? You should understand. What are the techniques used here? Clustering techniques are used. What is the fundamental working procedure of clustering? They are going to identify the common characteristics among the objects. Depends upon the similarities. It is going to identify different subgroups. Right? So please try to understand. If you can able to concentrate this class, this 1 hour of time, definitely, and I will guarantee that you can able to score 100% in fourth unit. But even you are joined, you can listen. This is even first hour. Why you are not putting that much effort? I am really telling you, if you lose the hardworking nature, if you want to make the things simple, you can't able to become a successful employee. You are thinking that you got a job and you can learn anything by referring YouTubes or some other sources. Okay, if you lose your listening skills, if you lose your concentration, you will never become successful person in any of the field. The basic thing you are not responding, you are not able to understand means you inspect yourself where you are. No one is there to ask me whether I taught the subject or not. Simply I will keep the heading and I will go to the next topic and I will complete the syllabus also. Even I can say that I have completed all 5 units. Why I am showing interest? You can learn something beyond whatever you study and whatever you learn. More than that I can give. That much confidence I am having. More than your perceptual capabilities, my perceptual capabilities are double. Very good knowledge I can able to give if you can able to concentrate. You are not concentrating. If you fail to answer that simple question means whatever I am planning to teach, all my motivation will gone. I am thinking that you are not listening. Why should I struggle? Hmm? It's very unfortunate. With this kind of attitude and with this kind of working culture, hardworking capabilities, if we are sending you people into industry means definitely you will bring bad name to our college. Luckily, this particular branch is having lot of vacancies. You are getting jobs. You remember that. I am seeing you people from 2 years. Even you can't understand a very basic thing also. Yeah, as I mentioned, there are different types of clustering algorithms. Clustering approach is one of the unsupervised learning technique. In clustering, first type is partition based clustering. In the partition based clustering, k-means clustering algorithm is one of the famous clustering algorithm. Today we will try to see how k-means clustering algorithm works. We will try to understand the working procedure of the algorithm, and we will see with an example how k-means clustering algorithm will work and what are the advantages and disadvantages of k-means clustering algorithm. If time permits, I will show the Python implementation of k-means clustering algorithm also. Okay. So k-means clustering algorithm is one of the unsupervised learning algorithm, right? Up to this, I think everyone clear. Next, given a data set of items means given a set of items with certain features. Okay, certain features means like as I mentioned, a bank customer will have different features like salary is going to have, number of children is another feature, whether wife is working or not is another feature, whether he is having own house or not that is another feature. So a data set given with certain features and values to those features, then algorithm will categorize the items into k groups or k clusters, depends upon the similarity among those features. You understand? I was given 1,000 customers, all those details. Then depends upon the values of those features, algorithm can able to divide them into different groups. Okay, different groups means k groups. Here the value of the k we need to mention. So k groups it can able to divide. Either you can call them as groups or clusters. How it can able to divide them based upon the similarities among the objects. Here object is what? Every bank customer is an object. Customer 1, his features are there. Customer 2, his features are there. Like that 1,000 customers are there and their different features. So depends upon the similarity of the values in their features, these 1,000 customers can divide into k clusters. That is the main objective. So here what is happening? We are partitioning a set of data set into different subparts. That's why it is called as a partition based clustering. Means partition means we are dividing a group of elements into different subgroups. Okay. So here to calculate the similarities between the objects, we can use different kinds of distance measuring formulas we are having in our mathematics, such as Euclidean distance, Manhattan distance, Hamming distance, cosine distance. These are the different formulas we are using in order to measure between different objects. Okay, so we'll try to see the k-means clustering algorithm procedure, how it works. Okay, so rather yeah, we'll look into this flowchart for better understanding. Yes, very simple algorithm. If you put a little effort, you can easily understand. I'm giving 100% assurance. Everyone can able to understand. Okay. Initially, what we are going to have, we are going to have a set of data items. Okay, a set of data items we are going to have. With those set of data items, we are starting. Okay, we are starting. Means there is no label like it is triangle, star, square. Okay, we don't have any label. Just we are having different objects. Assume that these are the four objects we are having in our data set. First, what we need to do is we need to decide k value. How many number of clusters we want to divide. So my k value is 3, then I need to divide this entire data set into 3 clusters. So initially I am forming 3 empty clusters, means identification of k value is nothing but deciding how many number of clusters we need to divide this particular data set. This should be done by user, means human only need to done this. How we need to done depends upon the domain knowledge. How many possible clusters are required by looking into the data set. The user should decide number of clusters. So k value should be decided by the user. See, in this example I have decided my k value is 3, so 3 empty clusters are formed here. Okay, then we need to identify centroids for each and every cluster. These centroids are purely random value. Suppose this is the point I am planning to consider as a centroid for this cluster. This is the point I am planning to consider for centroid for this cluster, and this is the centroid for this cluster. Okay, three random. These are purely random. There is no heuristic. Initially, we have identified 3 clusters: C1, C2, C1, C2, and C3. 3 clusters are identified. Then, second thing, we need to identify centers, random centers to these clusters, centroids. So we don't know which one is centroid. So randomly we have taken one point as a centroid. Okay. Next, distance between object to centroids. Here 4 objects are there. No, I need to calculate distance between this object to this centroid. Distance between this object to this centroid. Distance between this object to this centroid. Okay, distance we have calculated. For calculating the distance, we can use Euclidean distance or Manhattan distance, any of the distance measuring formula. So I got a distance 5 here. I got distance 6 here. I got distance 8 here, assume. Then group based upon the minimum distance. Next step is group based on the minimum distance. Means this particular point is nearer to which cluster? Cluster 1 it is having distance 5, cluster 2 it is having distance 6, cluster 3 it is having distance 8. So to which cluster it is very much nearer? It is nearer to cluster 1 when compared to 2 other clusters. So grouping based on the minimum distance. So it is nearer to this. So I am keeping this particular object here. I am keeping this particular object in this cluster. Right? Second thing, second point, second step what we need to do, we need to repeat it for same. Repeat the same procedure. Take this one. Calculate distance between this object to the center of the cluster 1, this object to the center of the cluster 2, and this object to the center of the cluster 3. Okay. Then different values. Assume that I got a value 7 here. I got a value 5 here. Means these are the distances. Assume. And the value. How to calculate distance also I will show you with an example. At this point you understand that distance was calculated and distances are mentioned as from this object star to cluster 1 7, star to cluster 2 5, and star to cluster 3 6. Where it is having minimum distance? It is having minimum distance with cluster 2. So group based on minimum distance. So I am adding this particular object into cluster 2. I am adding this particular object into cluster 2. Okay. Next, same procedure with remaining objects also. Same procedure with remaining objects also we need to do. Okay. Suppose I am taking this symbol and calculating distance between this one to center 1, this one to center 2, and this one to center 3. And assume that corresponding distances, this is getting value 7, this is getting value 8, and this is getting value 3. So this particular object is nearer to cluster 3. So I am adding this particular object into cluster 3. Like this, we need to repeat the process. Then, once all these objects are shuffled across these 3 clusters, okay, shuffled across these 3 clusters, then we need to calculate mean of this particular cluster, mean of this particular cluster, and mean of this particular cluster. The mean value, whatever we are getting now, that will become the new cluster center. Okay, that will become the new cluster center. Suppose C1 we are having 2 points. Okay, this point and this point. Okay, so first point is 1 comma 3 assume. First point is 1 comma 3, and second point is 2 comma 3. Second point is 2 comma 3 assume. So how to calculate mean? You add x coordinates 1 plus 2, 3. 3 by 2. 3 by 2 is one thing, and simply you can add y coordinates also 6 by 2. 6 by 2. So 1.5 comma 3. 1.5 comma 3. So the new center for this one is 1.5 comma 3. Like that, we need to calculate new centers for all these clusters. 1.5 comma 3. Like this, we need to calculate new centers to all these. Okay, then all the objects available across these three clusters, we need to repeat the same process. Distance from the centroids, group based on the minimum distance. Okay, when we need to stop this particular one, when no object is moving from the group, suppose all objects available in this particular cluster are still same with the new cluster center also, then we need to end the process. When object is moving from this cluster to this cluster, when new center is formed, then we need to repeat the same process. This cycle will repeat until objects are not moving across the clusters. Until objects are not moving across the clusters. How many of you understand this particular algorithm? How many of you understand? Can I explain again or you have understand? That is my question. Tell me yes or no.
Sir, can you explain that new cluster again?
Yeah. I will take an example here. You can understand how it is working. So this is my data set. Okay, please concentrate here. This is my data set. This particular data set is having how many points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points are there. X, variable X and variable Y. There is no dependent variable. It is purely an unlabeled data. Okay. Now I need to calculate distance between each and every object to the center. First, what I need to do, I need to identify three cluster centers. Assume that I am planning to divide this entire data set into three clusters. So initially what I need to do, I need to create three empty clusters. Three empty clusters I need to identify, and randomly I need to assign 3 points to these three clusters. That is the first step. So see, if I plot these things in a 2D space, these points 2 comma 4, 2 comma 6, x coordinate and y coordinate and x coordinate. In this is the view I am going to get when I can able to plot them into a two-dimensional space. Okay, this is the actually center, initial center. Now I want to divide this entire data set into three centers. So I need to identify three random points, three random centers to this particular data set. So these are the three random centers I have identified. These three are purely random. There is no heuristic. All are purely random. So here in this two-dimensional space, this is one center randomly identified. This is another center randomly identified, and this is another center. Three clusters empty clusters. Number of clusters are identified. Second step, we need to identify the centroids. Yes, centroids are identified. Three centroids are identified for three clusters. They are randomly. Then third step is what? Distance of objects to the centroids. We need to calculate distance of object to the centroids. See here. So the initial centroids taken for three clusters are these points. 1.5 is the cluster 1 centroid, 4.1 is the cluster 2 centroid, and 6.5 is the cluster 3 centroid. 6.5 is the cluster 3 centroid. 4.1 is the cluster 2 centroid, and 6.5 is the cluster 2 centroid. 6.5 is the cluster 3 centroid. 4.1 is the cluster 2 centroid, and 6.5 is the cluster 3 centroid. 4.1 is the cluster 2 centroid, and 6.5 is the cluster 2 centroid. So the initial centroids center 2 seed point, center 3 seed point, three clusters, 3 points identified. Okay, for calculating the distance between center to the objects, we are using a formula Manhattan distance, square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is my data set, and these are the three centers: center 1, center 2, means cluster 1, cluster 2, and cluster 3. Okay, so what I need to do here, I need to calculate distance between these 2 points to this, these 2 points to this, and these 2 points to this. Okay, if you see, if I compute the distance between these two, how I need to compute? This is x2, assume x2 minus x1 whole square plus y2 minus y1 whole square. Okay, then we are going to get this particular distance 1.41. Same this point to this center 3.61. Next to this point to this center 6. So out of this, to which cluster we are assigning this particular point, wherever we are getting minimum value, to that cluster we are assigning this particular point. Why cluster number was mentioned C1 here? Because this particular point is having minimum distance with cluster 1 when compared to cluster 2 and cluster 3. That is the reason why this particular point is assigned to cluster 1, right? Then second point 2.6, same procedure. We need to calculate distance between this point to center 1, center 2, and center 3. If I compute center 1 distance 1.41, 5.39, and 6.32. Again, it is having minimum distance with cluster 1, so it is assigned with cluster 1. Like this, all these 10 points, distances are calculated to 3 centers, and wherever it is finding minimum distance, that particular point is assigned to the corresponding cluster. In this way, 10 points are assigned to different clusters. C1, how many points assigned? 1, 2, 3. 3 points are assigned to C1. Okay, C3, 1, 2, 3, 4, 5 points are assigned to C2, and 2 points are assigned to C2. Sorry, C2 and C3. Okay, you understand this particular step now? This is our data set, and these are the randomly identified cluster centers. Okay, as per our algorithm, what we need to do? We need to calculate the distance of each and every point to the cluster center. Okay, this is our point. This is our object. These are the cluster centers, cluster 1, cluster 2, and cluster 3. By using this formula, we need to calculate distance between this point to the this center, this point to the this center, and this point to this center. The values are 1.41, 3.61, and 6. Out of these three, 1.41 is minimum distance, so this particular point is assigned with cluster 1. Up to this, I hope everyone clear. Okay. Once clusters are identified, then we need to find out centroids. Earlier centroid is random centroid. Now we need to identify new centroid. How to identify new centroid? By calculating mean value of that particular cluster. Assume that cluster 1 is having, what are the values cluster 1 is having? Cluster 1 is having 3 points. Okay, cluster 1 is having 3 points. That is 2, 4, 1 point, 2, 6, other point, and 4, 7, third point. These are the 3 points assigned to cluster 1. So how to calculate 2 plus 2? 4, 4 plus 4, 8, 8 by 3. So 2.66 is the center of x coordinate for cluster 1, and 4 plus 6, 10, 10 plus 7, 17, 17 by 3, 5.66 is the y coordinate centroid. Like this, we need to calculate for C3. C3 we are getting 6.5, C2 we are getting 4.5 and 3. Now the table structure will change. If you see here, now the new centers are these 2.66, 5.66. Why? Because we have calculated the mean, because earlier center was randomly taken. Now we are trying to come to a original center through calculating the mean of all the points. Mean is what? Mean is nothing but center point. So we are iteratively calculating the mean of all the objects in the particular cluster, and we are trying to come to a original center. Initially, we don't know which one is center. So initially, we have taken a random center, and iteratively we are trying to come to a original center. Okay, that is the main intention. So in iteration 2, you need to observe one thing here. You need to observe one thing here. That is, your data set is same, common, x and y values are same, all 10 values are same. Now center 1 changed, center 1 value changed, center 2 value change, center 3 value, center 3 value also change. Right, now we need to calculate again distance between this particular point to center 1, this particular point to center 2, this particular point to center 3. The values are these 1.79, which is minimum among these three. So it was assigned to cluster C1. Same procedure, 0.74. So again it was also assigned to cluster 4. It is repeated for all the points, C3, C1, all the points it was repeated. Okay, when we need to stop, when objects are not moving across the clusters, we need to stop. But here, is there any change when compared to the previous clusters? We need to observe. If you take first cluster, first point, second point, and fourth point are there. Okay, first point, second point, and fourth point are there. So there is no change in the cluster one. Okay, where change happens? See, where change happens. If you take C2, C2 it is having 3 points. Here C2 also not changing. Same objects are there in the C2 also. There is some change in the C3. Okay, there is some change in the C3. Right, there is some change in the C3. When objects are moving across, where it was happen, where change was happen also we can observe from previous cluster to this. 1, 2, 3, 4, 5, 6, 5, 6, 8. 1, 2, 3, 4. Earlier, if you see 1, 2, 3, 4, 4 are there in cluster 3. If you see here, how many are there? 1, 2, 3, 4, 5 are there. Okay. Means one value changed from cluster 3 to cluster 2. There is a movement among the objects. As per this algorithm, what it is telling, no object moving in the group, then we need to end. When objects are moving, again we need to repeat this particular process. So here C3 is having 5 objects earlier in iteration 1. If you come to iteration 2, it is having only 4 objects. So there is a change. So again depends upon the clusters. We need to calculate the mean values centroid for all the objects in the cluster. Cluster 1, 1, 2, 3, 3 points are there. For those 3 points, calculate the center. Okay, cluster 2, how many points are there? 1, 1 point is here. 2, 3, for these 3 you need to calculate. And cluster 4, okay, cluster 4 we need to calculate these things. Means cluster 3 also we need to calculate the means. These are the new means again. network issue. Yeah, as I mentioned, we need to understand this particular flowchart. First, initially, as I mentioned, you need to identify number of clusters. Once clusters are identified, based upon the number, we need to form three empty clusters. Assuming in this context, my k value is 3. Then identify centroids, means random centers we can assign to three clusters. Then we need to calculate distance of centroids to the I hope all of you understand all of you understand.
Yes, sir.
Yes, sir.
Right, I will take a quick attendance. Tomorrow I will discuss other type of clustering, like hierarchical clustering is there. In the same way, I will discuss hierarchical clustering also. Here, one problem is this k-means clustering algorithm. Main drawback is it is very much sensitive towards outliers. Outlier means a particular value, a particular data point is having an abnormal value, then the entire clustering scenario will varies. The mean value will change. The point will distribute differently. You understand now? All points are 2 comma 3, 5 comma 6, like that. All different points are there. When a particular point is having a bigger value, means 1 lakh comma 2 lakhs, then the outlier definitely shows some impact on the formation of the clusters. So one of the major drawback of this particular clustering algorithm k-means is it is very much sensitive towards outliers. Very much sensitive towards outliers. Rest of the cases it can work on any type of data set very effectively, and it is one of the prominent clustering algorithm. But it will fail when you are failed to clean the data. In pre-processing, if you are cleaning the data, the outliers will be removed. Right. That is the main thing. We will take attendance. 520, 18 series 520,
Present, sir.
H naught, H naught,
It's not present.
19 series 508,
Present, sir.
next 507, 18 series, Monica,
Present, sir.
517,
Present, sir.
G7,
Present, sir.
506,
Present, sir.
Rajeshwari, what is your number? 5?
539, sir.
539. Yeah, D7,
Present, sir.
E3,
Present, sir.
556, Sonarbita, 556, D naught,
Present, sir. 5.
Present.
530,
Sir,
5:30
D not
present.
present.
D not noted. 5:13. Vani.
5:13 present, sir.
5:38. Vivek. Okay, then we'll meet in the next class.
Sir, 18 since I H not, sir.
H not. Okay, noted.
Thank you, sir.
5:20 present, sir.
5:20 you are not there, I think, in the meeting. Now you join.
No, sir, I have John started only.
5:20. Okay.